Welcome you all. In this video, we are discussing the topic about segmentation. Segmentation is another way of dividing the addressable memory. It is another scheme of memory management and it generally supports the user view of memory. The logical address space is basically the collection of segments. Each segment has a name and length. We simply try to convey that segmentation is just to be segmenting the whole memory or we dividing the memory. Like paging, segmentation divides or segment the memory as I said earlier. But there is a different and that is while paging divides the memory into fixed size. And on the other hand, the segmentation divides the memory into variable segment. That is primary difference between paging and segmentation. Here there is a two type of segmentation there, virtual memory segmentation. With this type of segmentation, each process is segmented into n division and the most important thing is that they are not segmented all at once. Here in simple segmentation with the help of this type, each process is segmented into n divisions and they are all together segmented at once exactly. So simple segmentation, they are all together and segmented at once exactly. Virtual memory segmentations, n divisions and the most importantly, they are not segmented at all once. These two matters are important when we focusing virtual memory segment and simple segmentation. Characters of segmentation. Segmentation partition scheme is variable size. Partitions of the secondary memory are commonly known as segments. We discussed that segments. We can also say as a block. Partition size mainly depends upon the length of the module. Thus will help of the technique secondary memory and the main memory are divided into unequal size partitions. So we can easily understand that in segmentation there are unequal size of partition memory. But we focus on paging, it have a equal length, fixed length of each dividend. Each dividend portion have a fixed length. Naturally, the user view of program, you can say in the diagram, user view of program, we use that using personal computer, the user actually using operating system in a different purpose. We know very well whatever the system, the operating system is very important. When a user using on personal computer, he makes some interactions easily. The same user connected with on a mainframe or mini computer, he connected with resource utilization. When a user sitting on workstation connected to other workstation network, then the operating system needs to focus on both individual usage of resource utilization and sharing. If the same user using on handheld computer such as a mobile, the operating system handle the usability of the device including a remote operating system. So that whatever the system may we use, we need an operating system. So operating system also used by for a user in a various perspective. That are that we need to store a content in that memory. The operating system provides such a type of facility, whether a segmentation or paging. By the way, it managing such a type of things for the different view and different usability for the users. Segmentation hardware. Although the user can now refer an object in the program by two-dimensional address, and the actual is physical memory, we know that, and then logical memory. We must define the implementation to map two-dimensional user defined address into one-dimensional physical address. This mapping. So simply we need on a mapping. We actually store on a content physical memory in a physical address. System also assign on a logical address. We need to interconnect with them. We made on a division based on the segment. We all know that it's on variable size. That's a matter. For whatever we do on a mapping, we need some values that is on segment table then, and then we have on a base and the limits registers in a segment table. So in a particular physical memory location where the address memory started, from where to where it will be located. Further details, it need a segment base and the limit. So the diagram shows that after that CPU, after that bit CPU on a process, it have a segmentation. So the segmentation have a limit and base. So that are recorded in the segmentation table. So here we focus on that. It will not affect on OS memory, OS stored location. So after that OS location, there should be a space for a user. Only it will store the content in the user's view. Suppose the address does not consist within the limit of user layer, user level, it will be decline and trap on addressing there. So the address must be in a user range. Suppose my computer have 0 to 1000 only the address range in the sense, the segmentations, all other things are done within the 1000 address. Right? Here on an example of segmentation, you can easily view that there has been a number of things there. We have focus on limit and base. Say for example, in the segment table, we have considered the segment is 0. The segment 0, the starting address is, that is base address is 1400. We have a limit as 1000. So 1000 lines of instruction or 1000 address you may take. 1400 plus 1000 is 2400. So that was the region of segment 0. Likewise, you can compare all other remaining values base with the limit. So sharing of segment in a segmented memory system, the diagram clearly explains that. We have process 1 and process 2. Actually, we see in the previous slide the limit and base importance. Here, the process P1 and P2 have a editor and data 1, data 2. When you look it up, the both process have a same editor, which means same address space. Here, the same address area shared by the process P1 and P2. That's another relevant topic is on fragmentation. The process of dividing a computer file such as data file or an executable program file into fragments that are stored in different parts of computer storage medium, such as its hard disk or RAM, is known as a fragmentation in computing. When we say a file fragmented, it is stored on the storage medium in a non-contiguous block, which means that the blocks are not stored next to each other. So continuously, it is not stored in the continuous manner. Whenever there is a free space, it will be there. So fragmentation is all about you can store some element. After that, you making continuous deletion there. So when you deleting there, when you deleting some data from one memory, it creates on fragmentation. It creates on some free space. So there should be two types of fragmentation. One is internal fragmentation. That way I am illustrated here in on some detail manner. If a system allocates 64 kilobit of block memory to store a file, only 40 KB in size that the block will contain 24 KB of internal fragmentation. That is free memory. So to overall they have a 64 KB, only 40 KB is allotted, so remaining 24 KB is on internal fragmentation. External fragmentation occurs when a storage medium such as hard disk or solid state drive has many small blocks of free space scattered through it. This happens when a system creates and deletes files frequently, leaving many small blocks of free space on the medium. I am already told that. In the diagram itself also you can say there is an here and there on a fragmentation. That is on external fragmentations. So when we look it up all about on segmentation, we have these type of insights in that segmentation topic. I hope that this video will help you to know about segmentation. Thank you.